Alright, in this video we're going to look at the sine rule. The sine rule is one of two rules, along with the cosine rule, that allow you to solve non-right angled triangles. So the sine rule and the cosine rule together allow us to solve non-right angled triangles. So far we've been using SOHCAHTOA, which gives us the three equations: sine equals opposite, sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, tan theta equals opposite over adjacent. Gives us those three equations, and those are great for solving right angled triangles. They're terrific for doing that. But when it comes to a triangle that doesn't have a right angle in it, so that's great for SOHCAHTOA. But when it comes to solving a triangle that doesn't have a right angle, SOHCAHTOA is no help to us. We need to use the sine rule and the cosine rule. In this video we're only going to look at the sine rule. We'll look at the cosine rule in another video. So we're just going to focus on the sine rule. So the sine rule is going to help us when we've got a triangle of any shape. As long as it's a triangle, then the sine rule will be able to help us. But actually only in certain situations for that triangle, and we'll see what those situations are very shortly. But let's say we've got a triangle that's like this one here. It's got three angles. We'll label them with big letters, so capital A, capital B and capital C for each of the internal angles in there. That's how we'll label those. And each of the sides we'll label with a lowercase letter, which is each of the sides is opposite the corresponding angle. So capital C angle has on the opposite side small c, and this side here, small a, has opposite it the angle capital A, and side B, lowercase b, has opposite it the angle big B. So those are the three angles. For a triangle like that, this is the sine rule. This is the sine rule here. So it shows that there's three parts to it. Side A divided by the sine of angle A equals side B divided by the sine of angle B, and that equals side C divided by the sine of angle C, capital C. That's the sine rule. We'll see how to use it in a moment, but before we start using it, I'm just going to show you how it's obtained, how we get the sine rule. It's pretty simple, really. Okay, to see how we get the sine rule, let's look at a triangle that's not right angled, like this one here, and let's split it into two parts. So I'm splitting it down the middle with this line here, splitting it into two halves. Now you notice that each of these halves now is a right angled triangle. Let's call it right angled triangle 1 and right angled triangle 2. Okay, we've got two right angled triangles now. Now if we want to, now that we've got a right angled triangle, we can use our SOHCAHTOA rules to describe the relationships in this triangle and to find, any sides that we don't know. So we've got a name or a label for each of the sides in this triangle, in each of these two triangles, except for this one over here. We haven't given this line down the middle a name. This line that's shared, this side that's shared by both triangle 1 and triangle 2. Let's call it X. Let's call this line down here X. Okay, if we want to know what X is in terms of all these other sides, here's how we might express it. We'd say, okay, let's deal with this angle here, A, and since we've got angle A and we've got this side over here, X, which is opposite side A, then we can use the sine equation, the SOH equation, which involves the opposite. So if we take the sine of angle A, that's going to equal the opposite over the hypotenuse, which is, in this case, X over side C is the hypotenuse. So we've got sine A equals X over C. Now what we want to do is rearrange this equation in terms of X. So to get X on its own, we've got to multiply both sides of the equation by C, and then we end up with C sine A equals X. Terrific. Alright, now on this over here, that was triangle 1. For triangle 2, we can do the same thing. We can say for sine of angle C, that's going to equal side X, which is the opposite, over the hypotenuse, which is side A. So if we rearrange this equation in the same way, multiply both sides by A, this side by A, we end up with A sine C equals X. Okay, so now we've got two different equations that both equal X. And if C sine A equals X and A sine C equals X, well then we can say that these two things are equal to each other. We can say this: C of sine A equals A times sine C. Okay, we can rewrite that equation that way. And once we've done that, we can rearrange this equation like this. Watch what happens here. So if we divide this side here by sine A, and that cancels out, and we divide this sine here by sine A, then we'll have C equals A sine C divided by sine A. And then if we divide this side by sine C, which will cancel that out, and divide this side by sine C, then we'll end up with C over sine C equals A over sine A, which, if you recall earlier on, was part of the sine rule. It's two of the three parts of the sine rule. The third part was B divided by sine B. Okay, and to prove that, so we've proved part of the sine rule. To prove this last part here, all we'd have to do is split the triangle over here in a different way. Just split it down from this corner down to the middle of this line now, and we're going to find that sine of angle B is equal to, let's call this new line Y. It's going to be equal to Y, the opposite from angle B, divided by C, which is next to it, which is the hypotenuse. And over this side we're going to have sine of angle C equals, those aren't equal to each other. We're going to have sine of angle C equals Y divided by B. Okay, and we can rearrange that equation in the same way that we did this one. So we can end up with C sine B is equal to B sine C. Okay, and we can rearrange that from this point here. We can rearrange that to become C over sine C equals B over sine B. And once we've done that, we've shown that B divided by sine B is equal to C of sine C. So we've ended up proving that the sine rule, well, showing how the sine rule is derived, rather. So how we obtain this equation. Now let's see how do we use this equation. Okay, let's say for example we've got a triangle like this. We know this side's 5 meters, this side's 4 meters, and this angle here is 30 degrees. We're always going to need 3 pieces of information in order to solve a non-right angle triangle. For right angle triangles, we only need 2 pieces of information: a side and an angle, or 2 sides. We only need 2 pieces of information. But for a non-right angle triangle, we need 3. We need a little bit more info. Okay, so once we've got our non-right angle triangle and we've got 3 pieces of information, we can say great. As long as they're the right pieces of information, we can use the sine rule. So in order to do that, let's label the equation, label the triangle with the labels that we like to have, which means we need an A, a B, and a C. It doesn't matter which one's which, but once you've chosen which corner is each letter, you need to make sure that the opposite side is the same letter. So since this angle's B, this side has to be small b, and since this angle is C, this side has to be small c, and this angle's A, so this side has to be small a. So we've got to make sure that the letters are opposite each other. Alright, once we've done that, first step, well, that's the first step. The second step is write out the sine rule. Always write out the equation, write out the rule, at the beginning of a problem. It makes all the difference in the world. Okay, once we've done that, let's substitute in the values that we've got for this triangle into that equation. So A we know is 5 meters, and angle A we know is 30 degrees, so we're going to have sine of 30 degrees. And then side B we know is 4 meters. We don't know angle B, so we're going to leave that as B. And for C we don't know anything. We don't know the side or the angle, so we leave that one as it is. Now what should be apparent to you is that this is the part of the equation that we can work with. We're only going to work with 2 parts of the sine rule at any one time. Okay, we can't use all 3 at once. We choose the 2 that are going to be most useful to us, and in that case it's these 2. Okay, we're not going to be using the C sine C at this stage. We might come back to it later, but at this stage we're just going to use these 2 parts. Once we've got an equation like this, and we've got 1, 2, 3 bits that are known, we can easily find the 4th bit that we want. Okay, we've just got to rearrange the equation to get B on its own. So to do that, we've got 4 divided by sine B. We want to get that sine B on top. So we're going to multiply both sides by sine B. That's going to give us 5 sine B divided by sine 30 degrees equals 4. They've cancelled each other out. Okay, now we want to get rid of this sine 30 here, so we're going to do times sine 30 on both sides, times sine 30 degrees, and that's going to give us 5 sine B equals 4 times sine 30 degrees. Okay, we're slowly getting there. Now we've got to get rid of this 5 here. That's stopping the B from being on its own, so we're going to divide both sides by 5. So now we've got sine B equals 4 times sine 30 degrees over 5. And lastly, to get rid of the sine, we do inverse sine. That's gone. And we've got to take inverse sine of this whole other side. So the angle B is going to equal the inverse sine, or sine to the negative 1, of 4 times sine 30 degrees over 5. Okay, let's put that into a calculator. Okay, in the calculator we've got to go to the trig functions, make sure that that it's measuring in decimals here, and that over here the angles are in degrees, not gradians or radians. We want DEG for degrees. Okay, now we can enter this into the calculator. Inverse sine of 4 times sine of 30 degrees, close the bracket, and then divide all of that by 5 and close the bracket. And if we execute that, enter, we get 23.5, let's round the 7 up to an 8. So B equals 23 degrees 0.58. 23.58 degrees. If we want to convert that into degrees, minutes, seconds, we can go to interactive transformation and 2DMS, just go OK, and it takes the answer from the previous result and converts it into degrees, minutes, seconds. So let's write that as 23 degrees and 34 minutes, but it's 41 seconds, so it's going to round up to 35 minutes. So 35 minutes, there we go. So we've established here that angle B is 23 degrees and 35 minutes. Okay, now once we've worked out that this angle here, B, is 23 degrees and 35 minutes, that allows us to work out this third angle C, and we don't have to use any special rules or equations to do that. We simply have to remember that the internal angles of a triangle, A plus B plus C, have to add up to 180. And if we know that A is 30 degrees and B is 23 degrees 35 minutes, then we just have to take those away from 180 and we'll have the remaining angle, which will be C. So let's do that. Okay, so in the calculator let's type in 180 and then minus, and we want to add together 30 degrees and 23 degrees 35 minutes. So that's going to add together to be 53 degrees and 35 minutes. And if we want to put that in as degrees, minutes and seconds, then we're going to have to go to this interactive transformation to DMS. Actually no, not that one, interactive transformation DMS, and then enter in 53 degrees and 35 minutes, and then go OK, and the calculator's automatically deducted that for us. So 180 minus 53 degrees 35 minutes, which was these two angles added together, 30 degrees and 23 degrees 35 minutes, gave us 126.41. Let's turn that into degrees, minutes, seconds, and it's 126 degrees 25 minutes. So C equals 126 degrees and 25 minutes. So I can write that in here, 126 degrees 25 minutes. Alright, now I've got those three angles, I can easily solve for this side C using the sine rule. This time I'm going to include this part of the equation because now I've got an angle for C, so I can use this part of the equation, and I can combine it with either this part of the rule or this part of the rule because I've got all of these things now, little a, little b, angle A and angle B. I've got them all. I can work with any of them. Let's do that. Let's just create a bit of room over here to do that in. So let's say we'll work with A divided by sine A equals C divided by sine C. We'll work with those two bits. Let's substitute in our values. So A is 5 and sine A, sine angle A is 30 degrees, and that's equal to C, which is what we're trying to work out, divided by the sine of 126 degrees 25 minutes. Okay, we can actually use the calculator to solve this, so we already know how to solve it by hand the way we did it just before. Let's do it a different way by using the calculator. Okay, so to solve this equation, we've just got to enter it into the calculator. Actually before we enter that into the calculator, we've got to go to action and go to advanced, solve, and then enter the equation in. 5 divided by sine of 30, close the bracket, equals the unknown. For the unknown we're going to use x, which is this button just here, because we need to put an unknown value in. Let's use x for C, and then divide by sine. Now to put in 126 degrees 25 minutes, we'll go to interactive transformation and DMS, and then we can put in 126 degrees and 25 minutes and go OK, and it calculates for us that x, or for us it's C, but we're calling it x here, is 8.0, let's round it to 8.05. So that's a 7, so we'll make that 5. So C equals 8.05, and we're working in meters, so that's going to be 8.05 meters. So if we have 3 pieces of information, then we can solve for all parts of the triangle. Okay, but one more thing we need to be aware of is that we can only use the sine rule when we have 3 certain pieces of information, 3 particular pieces of information. Yeah, to use the sine rule, we either need to have 2 angles, any 2 angles, and 1 side length. So we could have angle A and angle B, and then any one of the other 3 side lengths. Or we need to have 2 side lengths, any 2 side lengths, and one of the angles that's opposite to those side lengths. So we'd need to have, if we had C and B as our side lengths, we'd either need angle C or angle B. Having side C and side B and angle A wouldn't work with the sine rule. We wouldn't be able to solve it. Okay, you can kind of see it by looking at the equation. You need to be able to take 2 parts of the equation, any 2 of the 3 parts, and have 3 of those 4 things. three of the four things in that in those two parts of the equation. That's what these two rules are basically saying. When you pick out any two parts of the equation, you need to have three of those four things there, otherwise you can't solve it. One thing to notice about this is two angles and one side length. It's conceivable you could have angle A and angle B, but the side length would be side C. So you wouldn't have 3 out of the 4 for any two. But the thing is, if you've got angle A and angle B, then you can find angle C straight away, because angle C will be 180 minus angle A plus angle B, because you know the sides of the triangle the angles have to add up to 180 degrees. So if you've got angle A and B, you can find angle C and use this one. Okay, as we'll see, the exceptions to this rule, the situations where we can't use these two these pieces of information to find and solve the missing parts, that's going to be when we need the other rule, which is the cosine rule. So in these situations we can use the sine rule. In those other situations we'll see later, we can use a different rule to solve the triangle. Okay, here's a summary of the information that we've covered in this video, and you can pause it here if you like so you can copy that out, and thanks very much for watching.